Alright, so the most important point on any parabola is always the vertex. So when we go to graph a parabola, one of the first things we're always going to want to try to do is find that vertex. Now notice there's a symmetry property that happens. If you start at the vertex and you take one step to the right, or if you take one step to the left, notice you get the same y values. If I go one to the right, the y value is 1. If I go one to the left, the y value is 1. If I go 2 steps to the right for this parabola, my y value is 4. If I go 2 steps to the left, my y value is 4. So the parabola, the vertex of the parabola is always kind of in the middle. So if I can find 2 things that have the same y value, the vertex is always going to be right halfway in between them. Alright, so that takes us a long way to how we're going to graph parabolas. Let's say I give you y equals x squared minus 4x plus 3. Here's what we typically do. We're going to build ourselves a table. And I'm going to plug my favorite number in the whole wide world in. What's my favorite number? 0, because it's always very, very easy to plug in. What's that? Worst column. Okay. I plug in 0. When I plug in 0, y is 3. Now, somewhere on this graph, there has to be another place where the y value is 3. Just like here, we had 2 places where the y value was 4, 2 places where the y value was 1. So I'm going to do kind of a weird thing here. I'm going to put 3 in for y and solve backward. Not something we normally do. Normally we always plug in for x. We're going to do a weird thing here. We're going to plug in for y. So if I plug in for y, I have 3 equals x squared minus 4x plus 3. You subtract 3 on both sides, you get 0 equals x squared minus 4x. Then this equation will factor. You can factor out an x. 0 equals x times x minus 4. So I get x equals 0. I already knew that answer. And I also get x equals 4. So that gives me 2 points that have exactly the same y value. So I'm going to start graphing now. Oops, very straight on that line, but that's okay. I have 0, 3 right there, and 4, 3. Once I have 2 points that have exactly the same y value, where's the vertex? It's going to be in the middle. It's going to be halfway in between. What's halfway between 0 and 4? 2. So my vertex is going to happen when x is 2. It's always going to be halfway in between those 2 values. So now I take 2 and I plug it in. When I plug in 2, I get 4 minus 8, that's negative 4, plus 3 is negative 1. So I have my vertex right here, 2, negative 1. So, notice what I've done so far. I found 2 points on the graph. One of them happens to be the y-intercept. That's always a nice thing to find. I found the vertex. The other points that would be nice to find would be the x-intercepts. Be nice, but as long as it's nice, we're going to do it. How do you find, we already found the y-intercept right here. It's when y would be 0. So again, I'm going to do a strange thing, something we don't normally do. I'm going to plug 0 in for y. So we're plugging in a lot of numbers for y here. How come I wrote 0 twice? Because there's clearly going to be 2 of them, isn't there? I mean, we can see that this is our vertex. So the parabola is going to go this way, and it's going to go that way. Clearly, there's going to be 2 spots, aren't there? So I know I'm going to get 2 answers. All right, so I have 0 equals x squared minus 4x plus 3. And now you need to decide how do you want to solve that equation. You can factor, you can with the square, you can use the quadratic formula. You can also use your calculator. Of all those options, I think I would factor because, again, I think factoring is the quickest and easiest one. Because it factors as x minus 3 and x minus 1. X equals 3, x equals 1. 3 and 1. So I can mark those. 3, 0, 0. So that's the kind of work I'm going to expect to see when you're asked to graph a parabola. I'm going to expect to see that first you find the y-intercept and then you find its other point at the same height. That will allow you to find the vertex, be halfway in between. And then you'll find the x-intercepts. Now, we'll see here in just a second, the x-intercepts don't always come out to be such nice numbers. Quite often they're not going to be nice. And we'll deal with that. We'll do the best we can. Alright, so let's try another one. Y equals. Let's go negative 2x squared plus 4x plus 5. Alright, so again, to do all the things we want to do, we start by building a table. And we plug in 0 for x. Easiest thing to do. When we plug in 0 for x, y is going to be 5. Alright, so then what we're going to do is we're going to turn around and we're going to plug 5 in for the y number. You always plug in the same number for y that you just got. So 5 equals negative 2x squared plus 4x plus 5. Why is it nice to use that exact same number 5? When I subtract the 5 on both sides, those just reduce out, don't they? So the reason I use that number 5 is that's always going to reduce out, and then my right-hand side is always going to factor. Always, and I'm always going to get a real nice answer. Because there's no number out here, I can always just take out a greatest common factor. Negative 2x. So I take out negative 2x. Left over? X minus 2. Yeah, watch out for that one when you take out the negative 2. Negative 2 times negative 2 gives me the plus 4 back. So we'll get x equals 0, which we already knew, and then we get x equals 2. Alright, so I can start drawing my picture. Zero 5 and 2 5. Where's the vertex? Halfway in between. What's halfway in between 0 and 2? 1. So the vertex will always be halfway in between those two x numbers. I plug in 1, I get negative 2 plus 4, that's 2, plus 5, that's 7. I have right here 1, 7. Well, I didn't quite draw that halfway in between, but it's close. Should have been halfway in between. And then finally, I want to find my x-intercepts. So I plug 0 in for y. I have 0 equals negative 2x squared plus 4x plus 5. All right, once again, I need to make a decision. Do I want to try to factor that? I could. Usually I don't. If this number right here is not the number 1, then I usually don't even bother trying to factor. I usually just jump right to the quadratic formula. So that's probably what I would do. I would go ahead and use the quadratic formula. Jump right in there. Feet first. I'm not sure it's what I want, but it's what I need. So, x equals negative b plus or minus square root b squared minus 4ac all over 2a Hopefully you've gone home and memorized that already, because if you haven't, well, you better do it soon, because you will need to know that. So that's going to be -4 plus or minus the square root of 16 minus 4 times -2 times 5 all over -4. So that's -4 plus or minus, good time to grab my calculator. Oh, I guess I really don't need it. It's 16 plus 40, that's 56. Over -4. And that's a shame, but this is reality. The x-intercepts don't usually come out to be nice, clean, friendly numbers. What I would probably do at this point is I would probably grab my calculator and approximate those. So, yeah, well, we hope for the best, but it doesn't always happen. -4 plus the square root of 56 divided by -4. One of them's about -0.87, rounding to 2 decimal places. And the other one, -4 minus the square root of 56 divided by -4. The other one's 2.87 approximately, rounding to 2 decimal places. And that's what you're going to have to do with those. You will generally not get nice, pretty answers for x-intercepts. You'll tend to get not so nice answers. All right, so I can mark those. -0.87 is right here. And then 2.87 is right about there. And draw my pencil. All right, so something I noticed about this parabola compared to the first two. The first two went upward. This one went downward. It is the negative number. So this number right here will control the direction of the parabola. If this number is a negative, the parabola will be upside down like this one is. If this first number is positive, like here it was a 1, here it was also a 1, if the first number is positive, the parabola will open upward. So when the parabola opens upward, your vertex is a low point, your vertex is the minimum. If your parabola opens the other way, if it opens downward, then of course your vertex is the high point, it's the maximum. Go ahead. Yes. So yes, I guarantee you that Friday I'm going to pass out a take-home quiz, something for you to do over break. I didn't want you to be bored. So I will pass out a take-home quiz. Bored, yeah. And I guarantee that there will be problems just like this one on it where you have to graph parabolas, and there will be a grid for you, and you'll draw the parabola in the grid. Okay. And then when we have our next exam, yes, absolutely, there will be problems where you have to graph parabolas. Guaranteed. Guaranteed. Money back. I don't know. It would depend on how many points the problem is worth to begin with. And I haven't written the test yet. That's way down the line. Not worried about that. What's that? You're not going to draw? It is your choice.
I'll just use my bonus points to get on.
All right. Now, what's that? A whole 4 points? Well, no. The next test covers more than just Chapter 7 because there's only 4 sections.
It covers all.
It covers Chapter 11 also. Of course, there's only 2 sections that we cover in Chapter 11, so I made it sound worse than it is. So there will be six possible bonus points for the next exam. Correct. Now, what if why? Yeah, because I feel like it. What if I gave you a problem like that, and I didn't give you any numbers, and I asked you to find the vertex?
Vertex would be
No. All right, so what did we do before to find the vertex? First we plugged in 0, didn't we? All right, so let's build a table and plug in 0. What do you get when you plug in 0? What's that? I get the y-intercept in this case. I'm plugging 0 in for x, which is c. All right, so this number c is important. This number c always gives us the y-intercept. That's an important number. All right, so I plugged in 0, and I got 5, and then I plugged in 5 for the y number. So now I plug in c for the y number. C equals ax squared plus bx plus c. And I subtract the c on both sides, and it goes away. It's really nice. Ax squared plus bx. I can factor out an x. Ax plus b. This one gives me x equals 0. And then I have ax plus b equals 0. Subtract the b. Ax equals negative b. You forgot the negative. X equals negative b over a. Alright, so again, going back to our other example. Once we had these two numbers, we said our vertex was halfway in between. So it's halfway in between 0 and negative b over a. So it's 1/2 times negative b over a. So 1/2 times negative b over a. We normally multiply the tops and multiply the bottoms, and we write it as negative b over 2a. And then how would I find the y number? Well, I would plug it in, wouldn't I? Okay, I'm not going to do that. That's a big ugly mess. The point is, here's a shiny little formula for finding the vertex. To find the vertex, you can just use x equals negative b over 2a. And then I heard Daniel say a minute ago, there's a formula for the vertex, but I can't remember what it is. It's negative b over 2a. But here's how you remember it. Look at this great big ugly quadratic formula that you've already memorized. If I take out the square root part, what do I have? I have the vertex formula. Vortex. No, not vortex. Vertex. There's a difference between vortex and vertex. So, the vertex formula is a piece of the quadratic formula. So if you've already memorized that quadratic formula, you get the vertex formula for free. It's a bonus package for memorizing the quadratic formula.
It's vortex. It's not vertex, it's vortex. It's sucking the lines down, and that's why you get a curved shape at that point.
All right, first off, these are not lines.
I mean, it's one single line, but there's a vortex. So it's angling.
It's clearly not a line.
It was a line.
No, it wasn't a line. Never a line. It was always a parabola. All right, so you might do this graph. Y equals, I don't know, give me some numbers to make up for 7x squared
66x
minus 66x
plus 6.
All right, so without doing a whole lot of work, you can find the vertex. Vertex x equals negative b over 2a. So that's going to be 66, negative, because b is negative 66, over 14. That reduces to 33 over 7. So you can very quickly find the x value. Now to find the y value, you have to do some work. How do you find the y value? I take that answer and I plug it in. So y is 7 times 33 over 7 squared. minus 66 times 33 over 7 plus 6. That sounds like a good one from my calculator. Why? Because I'm feeling a little lazy, like doing all that work with fractions. I get negative 1,047 over 7, which is approximately negative 149.57. So we picked some big crazy number, so we get some big crazy answers. That's what happens. All right, so if I want to start to graph, I can mark my vertex. 33 over 7. Where about is 33 over 7? A little less than 5, because 35 over 7 would be 5. So it's just a little less than 5. All right, so I'm going to mark 5 right here. And then 33 over 7 would be just a little bit less. Negative 149 over 57, that's way the heck down here somewhere. Somewheres. So there's 33 over 7, comma, negative 1,047 over 7. Is this vertex going to be a low point or a high point? What's the problem? What's that one? So the vertex is a low point. How do you know it's a low point? 7's a positive number, so this is going to open upward. All right, well, I can, without a lot of work, find my y-intercept. 0, 6. Right there. Just plug in 0 for x. Plugging in 0 for x is nice and easy. What about my x-intercepts? All right, so to find the x-intercepts, we need to take 7x squared minus 66x plus 6 equals 0 and solve that equation. And again, I think the only good way to solve that equation is to use the quadratic formula. So I would use that quadratic formula. In the interest of time, I'm going to cheat. Oh, it always works. Yeah. Yeah. So it's x equals 66 plus or minus the square root of 4188 all over 14. And that's approximately 9.34 and 0.09, rounding off to 2 decimal places. All right, so I've got just barely off the axis here, 0.09 comma 0, and 9.34, so that's about twice as far as that, right around there, 9.34 comma 0. And I draw a nice smooth curve, like so. So that's exactly the sort of work, minimal work, I would expect to see on a quiz or on a test. Questions about that? All right, so in problem 3 it says, a rancher plans to use 400 feet of fencing in a side of a barn to form a rectangular boundary for cattle. What dimensions of the rectangle would give the maximum area? What is the maximum area? All right, so we have a barn like so. It must be a pretty long barn. I'm glad you like my lovely barn. And then we're going to build a fence here. And we have 400 feet of fencing to use. We only have to build 3 sides. That's correct. We only have to build 3 sides. Well, 400 divided by 3 would give me a decimal, and that would certainly give me a fence. But I don't think 400 divided by 3 would give me the biggest area.
No.
Well, we're going to use up all the fencing, and we're going to build it so that we have the most area for our cattle to roam and to feed. All right. So, these two sides have the same length, don't they?
Yeah.
Since this is a rectangle. So,
The other two sides should.
and this one's different. Maybe. Maybe they're all the same. We'll find out. So, do I know how long I should build these sides? I don't think 150 is the right answer necessarily. Do I know exactly what they should be? No, so I give it a name, X. So I'll call this side X and this side X. How long is this side over here?
Y.
We don't know that one either, so we'll call it Y. All right, so it wants us to maximize area. Well, looking at this rectangle that I just drew, what's its area? How do you find area of a rectangle? Length times width. So area is XY. Well, not a whole lot I can do with that because it has too many letters. It's got X and Y. I'm only good with equations that have one letter. So I need to come up with something to get rid of one of these two letters. No. I think what I need to do is use the fact that I have 400 feet of fencing. I haven't used that information yet. What's that tell you? Not 2x times y, but rather 2x plus y. Why does 400 equal 2x plus y? I have to build two pieces of length x, but I only have to build one piece of length y, and I'm going to use all 400 feet of my fencing. I'm going to choose to do that. So I can write this as y equals 400 minus 2x, and we're going to take that and plug it in there. So area is x times 400 minus 2x, and then I'm going to distribute, and I'm going to put things in the right order. That's minus 2x squared plus 400x. I could take negative 2x out. I don't want to, but I could. What do I want to do? I want to find the maximum area. If I were to, I'm not going to do this, but if I were to graph this thing, what would it look like? Parabola. Does it open upward or does it open downward? How do you know it opens downwards? Because this is a negative 2. So this is a parabola that opens down. If I'm asking you to find the maximum, not the intercepts, where would the maximum happen? At the vertex. This is a parabola opening downward. The maximum is right here at the vertex. So anytime you see the word maximum or anytime you see the word minimum, the problem's really asking you to just find the vertex.
So is this only along the y-axis?
What do you mean is this only along the
It
y-axis?
says maximum, and that's the maximum on the y-axis.
Well, this axis is actually, this axis going up and down is actually the area axis. So this is the high, and on this axis is the x-axis.
So area is substitute y,
Yes, but not this y.
not this, yeah.
Yeah, so it's a little confusing, I agree. A little confusing. So area is pretending to be the y-axis, but not that y there. That y is a different thing. Should have used L and W for length and width, and it would have made more sense. But you guys told me to use x and y, so I'll put x and y.
Well, you picked X. I just told you to use Y to get you to that.
Maybe I picked x. We can go back and watch the video and see who picked x. Anyway, the point is, I want to find the vertex. How do I find the vertex?
Use that fancy vertex formula.
I use the fancy little vertex formula. X equals, what's the fancy little vertex formula?
Negative B over 2CA.
Negative b over 2a. So that's negative 400 over negative 4, that's 100. So x should be 100, which means I take that and plug it in there. Y should be 200. And then the area would be x times y, 100 times 200. 20,000? 20,000. What would be square feet? So, if I want to have the absolute biggest amount of area for my animals to walk around in, I should build two sides of length 100 and one side of length 200 and build my fence like that. Questions on that? All right, and then let's take a look at number 4. A person on the edge of a cliff throws a stone so it hits the ground near the base of the cliff. The stone's height, in feet above the ground, after t seconds, is given by that equation. All right, so first off it says, determine the vertex. How do I determine the vertex? I use my tiny little formula, t equals negative b over 2a, which in this case would be negative 30 over negative 32, because a is negative 16. That's 0.9375 if you want to go with a decimal. Then I take that number and I plug it in. I would have h equals negative 16 times that number squared plus 30 times that number plus 200. I get 214.0625. That would be in feet. All right, so there's the vertex. What does it mean in this situation?
After 0.9375 seconds.
After 0.9375 seconds, the rock was at 214.0625 feet, and that's the highest point the rock ever reaches when it hits the ground. When it hits the ground. The lowest it ever reaches is 0. That's when it hits the ground. All right, so with this tells you actually 3 things. At t equals 0.9375 seconds, the rock reaches maximum height of 214.0625 feet. So that vertex tells you 2 things. It tells you the time and the height. And again, because this is a parabola going downward, it tells you that that's the maximum height the rock ever reaches. So it's important, if you do this problem on a test, that you put the word maximum height in there. It's not any old height, it's the highest point. More important than all the other points.
No, it's not going to work.
Determine the h-intercept. No, I didn't. How do you determine the h-intercept? And how do you get that? You plug in 0. So t equals 0, h equals 200. What does that mean? At 0 seconds, height equals 200 feet. Or even better, this is the height when the person released it. So the person was throwing the stone, right as they released it, the stone was 200 feet in the air. So better would be stone was 200 feet in the air when released. All right, so now here's the question that you've already asked. Estimate the height of the cliff. How high is the cliff?
200 minus like 3.
A little less than 200, right? Because it's 200, I throw it from here. So 200 is where it's from here to there, and then all the way down.
Well, there is find out the height of the peak.
So it's a little less than the height of the person. So my answer would be a little less than 200. Maybe 196 feet would be a reasonable answer. Maybe the person's arm was about 4 feet in the air when they threw the stone. We don't know exactly how high the cliff is, but we know it's about a little less than 200 feet. All right, finally, did the person throw the stone upward or downward? How do you know they threw it upward? Because it started at 200 and it went higher. It went up to 214. So the answer is upward. Started at 200, went up to 214.0625. So it definitely went up a little bit. Not very much. You only threw it 14 feet in the air, roughly. It was just a light toss. It was just a light toss. He wasn't trying to fling it.
At least get some